Thank you so much. Thank you, Manikamis. Uh, Thank you for the MSDG program for inviting me as for my some experiences and some my knowledge to share with you all. It's my great pleasure, and I'm very privileged to share my thought, my views, how to jump or how to move towards the data scientist. I myself, Kamal Chabagai, is already introduced about me. So mainly today, my talk will be focused how we analyze data, how we use the data for our project work, and how we move towards the data scientist. That is the main aim. We will not talk much about the model and the other thing for today's session. Uh, Mostly we will focus on the data processing, how we do. So today is or this is the age of data. So me, myself, I'm shifting my interest from communication field towards the data scientist field. So what about the data today? So it's the about 2 to 3 years before, that is the old picture. But here we can see millions of data. The world is towards the data. For example, in the first 2.9 millions of emails in every second we have. And in each household, we have used 375 megabytes of the data set. And in each hour, we are using or we are uploading lots of videos. And we have lots of Google data set, and we have millions of Twitter, Facebook, and mobile data. And we have lots of order in every second. Amazon, they have a 72.9 items. That is the order from the internet. That means we have lots of data. So what the data is? So data is nothing but just the raw material, like a raw material. So if we see the data, then we have, if we analyze it, we can get some information. That is, when we analyze, when we see to the data, we can see some relation in the data. So from that relationship, we will get some information. So you can see here, this is a raw kind of data. But if we see some relation between these raw kind of data, we have some information if we see the relation. So we can have 3W, that means how the pattern looks like. That means we have the knowledge how the pattern looks like. Then we have few knowledge. And if we go through it a bit more, then we have some principal knowledge, then how this kind of data may be generated, then we have some understanding. That means why this kind of data or why this kind of pattern. And finally, we evaluated it to provide some wisdom information. So the main task of the data is to process it to get the wisdom. So Russell is the scientist who have developed this theory. So, so what we do is for the data, we try to find out the relation, what kind of relation is there. And then we try to find out the pattern, and then we try to find out or try to see the relation or the principle, what kind of principle is there. And finally, we will try with the model to give some wisdom, some good information, or some wisdom that we call as the wisdom. So this is the main aim of the data. So everything this is done by the, probably we all know about the data analyst, the data scientist, looks like similar, but there is vast difference. So data analyst is just a kind of who just analyze, who don't have much idea what does it mean, what is the main information. He just try to find the relation, and he just show the map or the figure or the picture like that. But the data scientist who try to figure out the pattern, and he try to build that on a proper model and try to get the wisdom information or the wisdom. So we define the data in that way. So everything this is done by the data scientist. So how we will be a data scientist? How to become data scientist? So this is the on your mark position, how to become a data scientist. That means how we use such kind of data in our project work. So for that purpose, these are the main three keys here we can see here. First, outside data knowledge, we have to know, we have some knowledge about the data. Then we have some basic mathematics. Obviously, mathematics should be there. And then we have a knowledge to visualize the data. So when we combine, for example, data knowledge and data visualization, between these two, we have a machine learning. Yeah, we have to know about some machine learning part. And when we discuss about the mathematics and the data, then we should have statistics over there. In statistics, we can see what kind of data is it, what kind of distribution it has, maximum, minimum. It's when most of the students, when they hear about the distribution, they think, oh, what could be the distribution? It could be the very big thing, but not. Distribution means just very simple how the data looks like. What is the maximum? What is the minimum? And is it in the normally distributed or not? Is it kind of skewed or what kind of data? It gives them some information. And obviously mathematics and data, then we have a programming skill. We need programming skill. Then only we will move towards the data scientist. So in my case, I really interested when I complete my master's, then I have a great interest to become a data scientist. So during my PhD, I try to find out where we can go to. So I try to pick up, I try to see from where we can learn. Like right now, Ms. Minaka also mentioned most of you are the bachelor student. So at the same time, when I complete my master, I think you and me looks like in the same phase. At that time also, I try to figure out from where we can learn. So I found, actually my aim was to be a data scientist, but I try to, I don't know how to become a data scientist. What thing we have, what kind of knowledge we should have. So I got a Kaggle. Maybe some of you already know about this Kaggle. Maybe some of you may not, but later you can Google it. So this Kaggle is the huge database and where there are lots of information, lots of solutions, lots of data, and lots of discussion over there. And I try to dive over there. And you can see in the Kaggle, you have lots of competition. You can see the $50,000 for the first prize, and there are other 25, 10,000. It's a very big amount of, there is the competition. And we try to learn, and I try to participate over there, but I was a kind of novice. And I also try to participate over there. You can see this is still, my notebook is there. Notebook means here, this is the Kaggle website. You can see overview data. You can get the data from here. If you click on notebook, you have several solutions over there, and there are lots of discussion and the leaderboard, whose position is where we can see here. So me also participates on some electricity price forecasting and some house prediction, house price prediction, like that. Though there are lots of people who are very talented. So, but if you know who win this competition, you will surprise. The Korean guy who is bachelor third year, he win this $50,000. He is the first in this competition. So people, they start on this field very early. So we can, but it's never late. You can imagine, after the age of 35, I try to dive in this field. But right now, I succeed to get some knowledge. So I can succeed to gather some knowledge on this field, and I can work as a freelancer. So everyone can do. You have lots of time for bachelor student or the master students. So these are some of my submission over there. For example, COVID cases, electricity price forecasting. Some I have submitted, some I haven't, but I try to learn. This is all about me. But You can see at the first stage, when I was novice student, when I tried to jump towards the data scientist, my aim was like this. I just want to get this kind of board, it like me. I don't know my background. I don't have any base on it, but I have to grab it without background, without any basis. So what the novice student do, or what I did in the past is, I just get the data, implement on the model. That's it. Just out from where we try to Google, we try to find the source resources everywhere. We try to Google, and we'll type some topic, for example, electricity demand forecasting, using machine learning with code like that. Then they provide some code, but that doesn't. Um, it's the what can I say? It's really not good. But for the learning purpose, it's okay. We can learn from here. But what we have to do is, the student who is novice and a bit competitor, he try to get the data, he try to analyze, and he try to find the proper model, what kind of data fit, what kind of model. He try to fit this and then implement on that model. But this is also, okay, this is also not the sufficient, this, because we have lots of steps. We have to lots of steps between this. So what are the main steps? What the real data scientist has to pass? We have to pass several steps before implementing the data on a model. You can see here, there are lots of steps. As far as possible, I have tried to minimize here. There are lots of things that are also not included over there. For example, loading of the data. It is just the load data. But what kind of data we have? We should have lots of data, not only little. We have by mega MB GB data. So loading the data set. Then we have to exploratory data analysis. That means we have to visualize it. Then we have to apply the feature engineering FE, that is some statistical analysis. And then we have to encode, because there are different categorical variables that we have to encode. Then we have to find out the base model and the parameter. What kind of parameter is the base? In that way, we have to find out the parameter. And then only we have to implement on the data set on that model. So this is the last step that we have to implement on the data set. But what we do at the beginning is just we try to find out the load data and we try to implement. I used to do that before, but in the case when you want to a real data scientist, or you want to make good project on your final year project or whatever you want, you have to go through the different steps. What is the role, or how we can do this? I will show you step by step. The first is loading the data. That means such kind of raw data we have to load, because we have the CSV file, text file. This is about the data set. We have audio, video, image, whatever the file we have, we need to try to load the data set first. But before that, let's know some programming tools, how we can load it. Regarding the programming tool, we have much popular Python, R, and the MATLAB. Everybody, every student, they know about, maybe they hear about Python, they hear about R and the MATLAB. Before 2015, I was use this MATLAB. I was familiar with this MATLAB, but this MATLAB is a kind of paid software. We have to pay the money for this. But these Python and R, they are open source. We have an open library. We have lots of functions, lots of help for this. That's why these days, the world is towards Python. Everything is possible from the very easy way, very handy kind of codes, very simple. But if you know the MATLAB, then it's all are similar, R and the Python. Normally Python and R almost, I can say almost 90% similar. But if we know the MATLAB, then it's also 50 or 40% similar with the Python. In my in my case, I prefer Python, and these days, last 3 or 4 years, I'm using Python. So these are some libraries that we have to use for this NumPy, Pandas, Matplot library, SciPy. These are the library for the Python. These are libraries are for the R, but the purpose are almost similar. Actually, MATLAB, they have their own library. So my focus or my suggestion for you is to go through the Python and know about the NumPy, Pandas, and Matplotlib. These three. For example, if you know the NumPy, what does it do? It's similar to the MATLAB NumPy. So NumPy means your data it makes in an array form, because in array it takes less memory. Memory is very crucial thing here. Later I will discuss about this, because memory, reducing the data set, memory, these are very crucial things. So in NumPy, it converts into the array form. And in the pandas, this is the library. Pandas means the panel data, lots of data you can, pandas helps to you to read the data, and then it helps to much more thing about the pandas. That means the manipulation of the data, lots of things we can do in the pandas. And then matplot library, and then you have a plotting library, we call it as the matplot library, and the SciPy, that is for the other process. So but in the beginning, how to install Python? Okay, so you can you can go to the Python org and you can download and you can install it. So you can run it different way. When you install the Python, you can run it in different way. There are some platform to run it. For example, I prefer Jupyter. In some cases, I use PyCharm, and some people they use Spider. When you are deploying your model to application form, this Spider is better. But for your purpose, for the students, normally today, I'm thinking my audience are bachelor and master students. That's why I suggest you to install Jupyter or the PyCharm, these two. Or some you can use Spider as well. But it's very easy if you have one software, all are inside this. For example, when you, from today, suppose you want to go to the Python, so just go to the Python and download it and install it. That's all. Then when you are running, when you are working, you need an editor. For that purpose, you can use the Jupyter or PyCharm or Spider, whatever you want. But I suggest you for Jupyter. So how you use this Jupyter? You have a Anaconda. Maybe you hear, or maybe some of you are already using. But Anaconda takes lots of memory. That's why I prefer to use Miniconda. It's also give all the things what the Anaconda does, but it have less memory. So I prefer, and I'm using this Miniconda. So when you install it, you will get this kind of graph, Anaconda Navigator, and you can make your own folder here, and on library you can install here. So you have Jupyter, PyCharm. If you have R, you can also run the R from here, everything. So first you have to install the program, either R or Python, whatever you want, and then you have to install this for the easiness, okay, for easy purpose. So I prefer this Anaconda. Then do not forget to install the libraries, these libraries. NumPy, I just tell you that it's for the, it is for array purpose for the data, and the pandas for the panel data analysis. That is, it makes for many things, manipulation of the data, for the dummy variable converting into, for encoding, everything, this pandas is used. And library for the plotting purpose, scikit-learn. So here, this scikit-learn you will use for pre-processing purpose. Then the SciPy is also similar. So in the last slides, we were talking about the loading the data. Okay, after all, you install all these libraries and all the things, then you can learn. You can open the Python, and then you can install, and then you can load the data. For example, loading the data, either you can load all the data at a time. For example, here I'm loading, this is a simple code. I'm not discussing much about code here. Maybe we need a different session for that. Just I'm telling you we can load all the data at a time, but I can tell you here is the path where my data is. But here, actually, in my case, these days I'm using Google Colab, that is Google Collaboratory. Okay, what does it mean? It is the platform that the Google provides us, because on my notebook or my computer, I have just 8 GB RAM and it's very slow. Lots of files here. But if you have internet, you can use Google. So in Google, you have a Google Colab. Then from there, you can play with it. There you will get 12 GB RAM. You can get the GPU. You can get the TPU, whatever you want. Lots of facility you have. That's why these days I'm using, so I showing here the path, and then I load the data. As a training data, I have a different file, not only one file. When you are working on the data, you will have lots of files. So here you can see this one data, and then here is the another in CSV form, okay? Comma separated value, or you can have a text file, or you can have the Excel file, whatever. But normally for the load space, people, they prefer CSV file. So here we read all these 3 data, and you can see the size, this 30,490 row and 1947 columns. You can see this is a bit bigger one, where it has 68 lakhs, I think, rows and 4 columns. So, and the calendar. So here, this data is for that M5 competition from the Kaggle, where from I downloaded it. And here, it's the task is to forecast what kind of items it's selling. So like a Bhatbhatini, what kind of items is selling by the Bhatbhatini. If we take all the data from different locations, Pokhara, Kathmandu. In Kathmandu, there are a lot of stores. So that kind of, you can see. So in the last time, I show you the rough kind of data. It was, now I read, and when I see, here you can see the ID, item ID, department, hobbies kind of data, categorical ID, store. This is from the American California first one, that means the store one. State is California, D1, D2. These are the sales, but here it's 0, 0, because if there is no sale, that is 0. So this item is not sold on that day, on the D1. So, but here is the millions of data. So most of this data now looking 0. So this is all about just the loading of the data. So after loading it, now you have to analyze this. Not only this, you have to analyze. Now I will show you another example, another kind of data. How here also we can see, but I will show you the other kind of data. For example, EDA, that is the exploratory data analysis. We can visualize the data. This is the data for electricity demand or the electricity consumption in Thailand for 2019. From here, what you can see is this is the area. 46% of the area is for industrial. The electricity is consumed. 46% of electricity is consumed in industrial area, and this is for the business. So what you can have some information here is from this visualization, you have some information. So from the raw data, now you will getting some information, and in agriculture you have some consumption here. So now from this idea, from this visualization, what you can think is, yes, the variable, when you are forecasting, suppose you are forecasting or whatever information you want to get, for that time you have to know the variables, where, what are the variables. So in these steps, in this visualization steps, you will get some information, some variables, it is called the feature. So we also call as the feature engineering, but feature engineering is the next one. But now we are telling about it as the EDA, that is the exploratory data analysis. So more about the electricity data, you can see here. So this is the intraday electricity demand. In one day, at the night, this is about the half-hour data. That is, in one day we have 24 hours. That means in half-hourly data, plot this one. So that means we have 48 half hour. Then what we can see is 10 means morning 5 a.m. So from the night, at the morning 5 a.m., electricity demand is decreasing and then increasing. It's going up, it's a bit down, it's a bit down, and this is the minimum. So what does it indicate? You can see here in the index. So Monday to Friday mean, when you see the Monday to Friday, this is the electricity demand. What you can see is after 5, people get up and then prepare the food and eat, and they went to office, and you have lots of demand up to 8,000 megawatts. And this is the kink over here. What does it mean is this is about the data set from Thailand. So this has lunch time. That's why it's down. And again, after lunch, office starts and again high, and then it's the 4 o'clock around here. People move to home, and when they are at the home, again the rise. Okay, demand is rising, and finally it's going down. So in weekdays, Monday to Friday, Sunday is holiday. That's why Monday to Friday is very high. But when you see this last one, what does it mean is New Year mean. So at the New Year, uh, everything is closed, all the industry, all the offices, they are closed. That's why demand is very low. Even though at the morning, other day, people get up around 5, but they when you sleep and get up late, and then at the evening only they have some demand and like this. So from here, what we understand is, yes, there are the different variable, Monday to Friday variable, Saturday to Sunday, other kind of impact. So the holiday, we have the different mean. So all these are the variable. That means when you are talking about the data, talking about the model, it's your task is to find out what are these features or what are these variables. So this is the thing. Then you have different graph and different variable you have to get. Then here I'm talking about the downscaling of the memory. So what does it mean? So for these cases, in this step, downscaling, I haven't talked about these things. I just talk about the visualize and how to get the variables. And here you can do downscaling, working with the data distribution, data imputation. What does it mean? So you can see data downscaling means the reduction of the size. For example, our demand, for example, if we talk about that electricity demand, it's up to 8,000, 10,000. When we convert it into binary, 32-bit is sufficient, 16-bit is sufficient. But our computer, my computer is 64-bit. So when we are representing it by 64-bit, a lot of zeros are there. It's just consuming our memory. So we have to reduce that because our computer should have minimum, because its data is less, then our operation is fast. That's why you can see here, we can downcasting means lots of reduction of data. So cells, the lot bigger, first that data, lots of size of 454 MB, which is reduced by almost 1/4 reduction. Similarly, price data and the calendar data is reduced. In this way, we can reduce. Similarly, in some data, there is nothing, means that is the null values. So null values, here you can see some yellow color which indicates the null, NN values. There are different reasons to denote the NN. For example, when you surveying something and you are asking some information, maybe some people, they not give you all information. For example, it's very common when you ask the age for the ladies or like that, the people, they maybe hide or they not reply for that. In that cases, it's difficult. For example, for the male, yeah, normally we used to say they not tell the salary or like that. So in that case, something is hidden. So we have to clean it, or we have to fill that any values, not a number values. So for that purpose, we have to use the imputation. We call it that the data imputation fill up. And we have to analyze some distribution. So, or when we fill up that, normally we fill by the mode or the median or like that. If all normally the age are 40, 45, 50 like that, then we can go, this is all maybe 50 or like that. In this way, we can fill it. So it's called the data imputation. But there are some outliers. You can see the outlier. What does it mean? So the outlier means which is not necessary. For example, here all are all are different color, but this one is green, this is red, this is the outlier. So here you can see the electricity demand. This is the graph, which is very down here. Such kind of outliers, you can see these are the outliers that makes unnecessary disturbances for the model. Okay? This, in most of the cases, we can use mean or median like this. For example, here you can see all these people, they can finish around 25, 26 seconds, but one finished the race around 82. But if you take the median, sorry, mean, it will be around more than 30. So all the cases, the mean is not good. Some cases we have to take median and we have to remove this. And if you do this, then there is the MAP error. Okay? Error is reduced before removing outlier. After removing outlier, we can see the different or improvement on the target or on the accuracy. So this is the reason why we have to remove these things. And then we have to find out the other feature engineering. For example, you have different variables. Okay, you have a different variables. They have all the variables. They're not given in a data set. You have to try to get yourself. For example, maximum, minimum. For example, if you, I will show here. For example, if you have a sales data, then hourly you have a different sales. In the morning you have different sales. In the day you have different sales, and the evening could be high. But at the electricity, it could be different. At the morning, at the day, at the evening, at the daytime, demand is high. So you have different varieties. So you have a separate kind of sales data and separate kind of feature for the sales. Similarly, you have a separate kind of electricity variable. So when you have a data, then you have to find out, you have to focus on that and what could be the features, what would be the thing, what would be the variables it affect our data. So from the figure, from the visualization, you can do that. So from here, maybe you can see here lots of variable. For example, sales. First week of the month, maybe most of the people, they get the salary and lots of sales over there. But at the last week, maybe money already finished and lower sale, whatever. So there are different reasons and there are different impact on the variable. All the variable we have to find out. But what would happen if you have lots of variables? If lots of variable is good, some cases it's headache. When some people, they go to buy a shampoo, and if there are lots of shampoo, then which one should we buy? If you have a different roads, which road we have to take? Because all the features may be not applicable on that model. That's why you have to filter down. How you filter? Actually, we will talk this later, but I will just trigger you PCA, maybe feature analysis and the PCA. Maybe some of you already heard about the PCA, is the principal component analysis, from where you will get the main features. Whatever the number of features you have, you can reduce it. Okay? So feature analysis, if you do feature analysis, and then you must do the PCA. This is the principal component analysis. And then still you have other thing to do. For example, now we are in the encoding stage. For example, here you have a male, female. Right now we are talking about only the data, mean, max, or only 1, 2, 3 like that. But these are also the variables. For example, if you have to predict the salary, then the variable could be your experiences. Experiences could be in the number, but master degree or PhD or the bachelor, that means the qualification. So this is a categorical variable. So that categorical variable you have to convert into the number. So here what we are doing is male, female. There are two types of variable in the sex variable. So here we are converting male, male and female. So in this case it is male. So female is 0 and male is 1. So we make the model like that. Y is equal to something x naught, beta naught plus female and plus beta 1 plus male, like that. When female is 0, then only the male is there. In this way, we have a model. So we have a very simple function how we convert all these things at a time, or we can get dummies. Very simple. very simple code in the pandas. We have get dummies. This is the data frame that is SX, this one. So it will produce this at a time. So this is the way how to, it's very simple. And then we have to select the model. Now we have to select the model. This is the very vast topic now we are here. If we talk on this, it will take a long hour. So, but in the short, in few lines, what I want to tell you is, popularly we have a MLR and the ANN, statistical and the artificial intelligence. It depends on your objective. What kind of objective you have. In that way, you can select either of one, either MLR or ANN. So anyone you can select, either MLR or ANN. So there are some literature. If you go to the literature, there are some literature. What they said is, before 1990, MLR was very popular, but after 1990, we have a computing machine, then MLR is popular. Sorry, ANN is popular. But later, in different competition, there is the very competition between MLR and this statistical and Bayesian and then ANN. But in some cases, MLR win the race. In some cases, ANN win the race. But there is in what condition, which one win the race? Everything depends on the feature engineering, on the pre-processing, everything that we did before. And what kind of data you have, it depends on that. And if you have to analyze the impact, then you have to go through the MLR this way. So main objective is to analyze the result. If we have a main objective is to analyze the huge data set, and that is the marginal change impact, then we have to go through MLR. Otherwise, if we only analyze the result, then we can go through the ANN. In ANN, we have feed-forward, recurrent neural network. Inside recurrent neural network, we have LSTM and gated recurrent units, and we have convolution neural network, lots of things over there. But at what case, what kind of model we have to choose, that is the prime thing that will be discussed later if we have a chance. So in this way, we have to choose, but any one is okay. It depends on your data, what kind of data you have, either linear data or non-linear data. Yes, there are the different methodologies how we choose. So in this stage, yeah, we already discussed about the PCA. On PCA basis, we will reduce the theater and we will try, for example, here I am considering the extreme boost. This is we call the XG boost, that is extreme boost, extreme gradient boost algorithm, where we are taking about the XG boost tree and the linear function in this two objective function, which will give the better result. Then we provide some data from score here, considering this is the base. यो भन्दा राम्रो भयो भने आउने भन्ने हिसाबमा we are providing some base error, and it will we have provide some parameter, and on the basis of that we are using hyperparameter search. So hyperparameter search means we have some parameter, and on that parameter we will provide some CV, that is cross validation, number of fold, we separate training and the test, and we will work on that. And if we have a lot of data in CV, what you do is, CV means cross validation. If we have a lot of data, then we chunk or we divide this much data for training and this much data for testing. And in later case, we make another folder, another CV, where it depends on time series data. Either it is time series data or it is general regression data. Okay? So maybe we will discuss more about the model in our order, but right now what we are focusing is pre-processing. What are the steps? So here what we can see is, yes, we are using XGBoost and we are using the parameter tuning, and then we are finding the best parameter, and then we are here is the random. So this is the optimizer, how we pre-process. Here we have made the 5-fold. Here you can see there is the 5. Here is the CV is equal to 5. That means we have given 5-fold, and iteration for 1 is up to 50, and we are using this one. And here in all 5 steps, they are calculating which one is better. And according to that, it find the minimum, or it find the parameter. And we use that parameter to forecast or to train the model at the final stage. So finally, we did this. We already got this data, this parameter from the first step here. And the final thing is nothing, just to implement it. This is the final step. So at the final step, we don't have to do anything. Normally, when we are novice, I already mentioned you, in my case as well, when I found the data, then I just use the data for this purpose. Just I try to separate train and test, and then I fit. I don't know what is the best parameter to fit. My data is either fit for this XGBoost or not. Maybe light boost, or maybe simple regression. There are lots of other algorithms or the other method. So if we go through this step, we can find out, we can test here, or we can use this one. So XGBoost, if we use here, this is good, but in all cases, we cannot say this one is good, because there are several other models. It depends on the data. Okay, so finally we do this. So our target for today is up to here, but for you today we haven't much discussed about the model, and if you really want to go through this model, how we find the model, either ANN is good or MLR is good, for that purpose we need some other a bit long time, but before that we have to go all these steps, how we manage the data. Okay, now what I want you is you go through this step and go and try to find out for the model, which model is used for what purpose. For that I can mention you from free online courses you will get from here. You can Google it. They have lots of free online and Google Live and many things. But what you have to know is which one you prefer. Let's learn to do, or let's do to learn. Which one you prefer? If you think first I will learn and then I will do, uh, if you think that, maybe you're wrong. First, let's do, then you will learn. Okay, thank you. Thank you. Thank you, everyone, for your kind attention. And if you have some queries, please, you can ask me. Actually, I have tried some statistical model, in what case we can use what kind of model and like that, but I'm thinking for today, this much is okay. So today, just I try to figure out the basic thing, how we go for the pre-processing steps, because any students and any data scientist, he have to pass 80 or 90% time for the data pre-processing. Okay, thank you.
Thank you, Dr. Sapagai. Now I would like to ask our audience if they have any queries related to the topic. So this floor is for discussion now. Any sort of questions? Or you can also leave the queries in chat box also, so that I can read them out. So Suyog, you wrote some question. It's quite long. I'm not sure it is question or not. Okay, anyway, I'm going to read out. If I have a lot of null values in the data set, should I have to avoid that data entry?
That's a very interesting question. Actually, I want to move on. Yeah, here. Uh, actually, uh, in this case, I have taken this data from uh, house price prediction. And here we can find there are different null values. Normally null values, they are neglected. If there are lots of null values, we will neglect it. But most of the cases, there are few values which are null. In that case, we refill it. We fill it. We fill null values with the help of this median or mean or that is mode. Which one is more repeated? More in this way we do these things. But it depends. That's why I focus you please go through detail on the data. For example, I will give the example. For example, suppose we have one variable that is for the age, and there are some people are 30, some 40, some 50, or some 80, maybe around there. Maybe we can take anyone, this mode, median, these things also okay. We can think this is also okay. But some null values, they contain the information. Okay, some null values, they contain the information. I can give you example. For example, when I was working on this one, same as your question, me too thinking, yes, I write the program that if there are more than 200 nulls, I will remove it. And all the null that I remove it, but it's not good because, for example, in house price condition, there is one variable, either there is a swimming pool or not on that house, either there is garage or not, because that depends, that makes the price different. But when there is no data, that means on that house, there is no swimming pool. That means price should be less. So it has some information. On that case, we cannot remove. So starting off the data is very important. Have you some idea? Clear? I think I try to figure it out. That is, in all the cases, we cannot neglect.
So for next question is for non-numerical data like the male-female data. Can we give arbitrary value to each one and convert them into numerical values?
Exactly. Yes, that's the thing before.
Yeah, you mentioned somewhere in the slide.
Yes. Yes, here we have mentioned this one. I have just talked a bit about it. Actually, here what we can see is, if you can see my slide, here, suppose we have an equation y this equal to, let's say, okay, we say the salary, this equal to beta times education, beta times education plus beta 1 times experience. So in this education, you have maybe bachelor, maybe master, maybe PhD. So you have 3 different values. When you give any arbitrary value, it means arbitrary means 0, 1, 2, like that. So it contains the much weight, because if you convert into the dummies like 0, 1, it has 0 and 1. It is the min max scaling. We have to make scaling as well. Okay? When we are pre-processing, when we have the high variance of data, it's not good. So we have to reduce to 0 to 1. That's why if we have some 0 and 1 data, that is, we have a facility by getting dummies to 0 and 1, we no need to make other assumption. But if you make other assumption, that is also okay. Arbitrary value is also okay. We should not be repeat. We should not be mismatch. If you give, for example, in Sunday, Monday, Tuesday, Wednesday, you can give Sunday 0, Monday 1, Tuesday 3, 1, 2, 3, like this. It's also okay. But your result is not good. That's why we have to go to the wrong concept. Just go to the good concept, that is the getting dummies. Okay? But here is the other case. If some student, they already heard about this getting dummies, there is the dummy trap as well, which I haven't discussed today. But just I am discussing how we convert the categorical variable into 0 and 1. Okay? But if you search on dummy trap, then you have some knowledge. How should we or how to clear careful? We should have careful when we convert this into the dummies. Okay, that is the thing you have to know about the dummy trap, which I haven't discussed today. But taking arbitrary is also, for your question, short answer. Taking arbitrary is also okay. It should not be repeated values, but you have some not good result. For good result, you have to make the dummies.
Okay. So I move on to next question, again from Suyog. If we have 0 as target data, should we omit those data entry or include them? How to calculate error in predicted value if the actual value is 0? So what
Actually,
if we have 0 as the target value? Mainly in case of supervised learning, right? He is, I think,
okay.
currently doing work in using ANN.
That's fine. Okay, okay. What I can figure out is I'm just reading your mind. I mean, what you are working, that I can figure out right now. I think you are working on the classical data set. Yes, we can. But today we are not talking about the supervised, unsupervised, and reinforcement kind of learning. In the classification problem, yeah, it's either 0 or 1. Okay, so our target should be 0. Either, for example, if there is the election, either Trump will win or some other that candidate will win. Okay, so we have, that is the different thing. Okay, that is under the classification. But today I think we are we only a bit focus on regression. Okay, maybe that's why we are talking like this. Okay? But for the for your question is very tricky question and very good question. I can say that, but that is on the classical. We cannot omit that 0 because that is our target. That is the classification like problem, or we can use the logistic regression for that.
Probably
That is,
he's saying that we already know that 0 target value is not correct value in itself, but from the measurement data we obtain 0 value, or from other mistake, we can say. So in that case, if I'm correct,
I
Suyog.
mean, I think if your target is 0 and we are getting other, that is our error. We have to consider this our error. But I think that is if your target is 0 and we are getting, of course we have to consider that as the error. Okay, that's very simple. I think maybe I cannot understand fully.
Okay, maybe he can communicate later.
Yeah, sure. You are very free to call me, or we can communicate. Don't worry for that. Okay.
Okay.
Actually, today maybe it's short time. We have to know lots of things on it. We have to. What I want to tell you, all students here, is you have listened. You have heard many big things. You have heard about convolution neural network. You have heard about deep learning. Many big things and many big algorithms. But the problem is, just I saw in the first that figure, we try to go there, but we need some base. Okay, from the base means from the basics. Okay, so in the first, let's understand how we process the data. Then in the second step, what are the what kind of models we have. Okay, statistical model, and then go to the AI. Then let's go to the AI, machine learning. And after you work and you learn different models on machine learning, then you have to go to the deep learning. And what are the algorithms? How For example, what is ensemble, what is machine learning, what is deep learning, what is RNN, what is MLR, everything, MLP. So this thing, step by step, you have to go. Okay. So,
Yeah.
so
Okay.
today we
Our main target was also like showing students how to move on, how to start
yes,
from
yes,
raw data and then how to move on to the
model.
final objective. So,
Exactly.
so you just included the methods in between
Yes.
and didn't talk about inside thing. So
Yes.
next,
First,
I would okay. Next question I would like to pick from the chat box again. Is there a special way to treat outliers in the time series? Because sometimes outliers phenomena is important in residential load forecasting. So question from Sri Krishna.
exactly. Actually, this is also my topic where I spent around 5 years,
Okay.
almost 5 years. Yes, yes. In residential forecast, in residential data, we have lots of outliers. Normally, uh, yes, but we cannot neglect that outlier, all the outlier from the residential area. So it's very difficult to predict. This is the main reason we cannot predict very well in residential area. For example, when you predict for whole week, Sunday, Monday, Tuesday, Wednesday, your error for other day is very nice. I mean, very low error. But when you predict on the holiday, when you predict on the weekends, the error is very high. It is due to the residential load, because in weekends, in the holidays, offices and the other industries, they are closed, and the most of the data is dominated by the industries. So when we forecast in aggregate data, that's fine. But when we talking about the residential, yes, it's the problem. You are right. In that cases, as far as possible, we try to minimize the outlier. We try to, if it is very high, my professor used to tell me that the outliers are the poisons. Outliers are the poisons at your kitchen. He used to tell me like that. Okay? As far as possible, we have to try to remove it. Otherwise, for the training purpose only. Okay, for testing we cannot remove. Only for the training purpose we have to remove, so that our model will be fine. Okay, so in your case, in residential area, as far as possible, try to figure out the distribution. First, you have to see the distribution, what kind of distribution you have, then according to that you have to manage. Okay, there is not any function, already built function, which makes outlier already fine, but we can use different function. Normally more than 3% error we remove, or 3% up and down, that is with standard deviation more than 3%, we remove that, and other we keep it. If that is a simple formula, normally MATLAB and Python use it, but we have to customize ourselves for our purpose.
Okay. Any more questions? You can simply unmute yourself and then ask directly also. I guess we don't have any more questions now. Okay.
Is can
I
I
think
stop
we
my
have.
sharing?
Sorry, sir.
Huh? Huh?
I didn't get you, sir.
Oh, can I stop my sharing then?
Okay, sir. I think we are almost at the end.
Okay.
But then I want to take one question we have received just now in the chat box from RP Pradana. I'm sorry if I mistake if I did mistake in pronunciation. Thank you so much for your wonderful presentation, Professor Dr. Kamal. Talking about the data science and machine learning advancement, then is it possible to improve the technology by using smart home technology based on artificial intelligence development to decrease the daily energy consumption? So basically, is it possible to improve the technology by using smart home technology to decrease the daily energy consumption?
RP
RP Pradhana.
it looks like I don't know who RP Pradhana is. Actually, when I was in Japan, there was my friend from Indonesia, RP Pradhana. Seems like a similar name, but I'm not sure about him. Either he is or not. Anyway, of course, when we use the smart home meter, obviously, we can decrease our daily energy consumption. For example, in Japan, just before now, I saw the electricity demand curve for the Thailand case. But in case of Japan, the electricity demand is maximum at the morning hour. But in Thailand, the electricity demand is maximum at the day hour. So it is because of one reason for this is uh, different electricity pricing. And the other thing is the smart meter and smart system at the home. For example, they make their washing machine and other thing automatically on at the morning 3 or 4 hours. They are sleeping, but their washing machine they are running at that time. That's why when we are using smart thing or smart home automation technologies, obviously demand will be flattened. So if we see the electricity demand of Japan, it's almost flat. But in our case, it's very rise, it's very peak at the evening, and the very peak at the morning. It's like that. So obviously, smart technology obviously reduce and not much difficult to manage the load.
So I think we should stop here. My hair environment is quite disturbing because of dog barking. So
Miss, can I, hello, Miss. Can I ask one question to?
okay, Anil sir. Okay, no problem.
Namaste.
Maybe this is the last
Can I
question.
speak in Nepali? Can I speak in Nepali?
Sure.
ओके सर नमस्ते पहिला हैन धेरै समयपछि सरलाई यसरी कार्यक्रममा चाहिँ यसरी अगाडि बढाएको देख्दा एकदम खुसी लाग्यो हैन मेरो एउटा सानो क्वेसन थियो के सम्बन्धी भन्दाखेरि यो लोडसँगै सम्बन्धी हो थोरै फरक पनि होला कस्तो भन्दा मैले काम गर्ने बेलामा यो सिटको लोडको डाटा थियो है मसँग हैन त्यो डाटा भनेको मैले युज गरेको डिभाइसहरू पावर इलेक्ट्रोनिक्स डिभाइस थियो हैन पावर इलेक्ट्रोनिक डिभाइस भइसकेपछि स्विचिङ भनेको हाई फ्रिक्वेन्सीमा स्विचिङ गर्ने हैन हाई फ्रिक्वेन्सीमा स्विचिङ गर्ने भइसकेपछि हामीलाई पर सेकेन्डसँग को डाटा चाहिने भयो त्यसले गर्दा चाहिँ डाटा चाहिँ लोडको डाटा जुन अब हामीले नर्मली के गर्छौँ अब धेरै डाटा हुन्छ आइदर 5 मिनटको अथवा आवरली डाटा लिन्छौँ हैन अनि त्यसले गर्दाखेरिमा हामीलाई चाहिँ डाटा चाहिँ कम हुन जान्थ्यो हैन त्यसले गर्दा सिमुलेसन गर्न सजिलो हुन्थ्यो हैन तर मेरो केसमा के हो भने पावर इलेक्ट्रोनिक्स डिभाइस भएको हुनाले गर्दाखेरिमा मेरो सिटको चाहिँ स्टार्टिङ पोइन्टदेखि इनको पोइन्टसम्मको लोड डाटा हैन त्यो हेर्दाखेरिमा चाहिँ लगभग 5-6 घण्टाको डाटा भयो भने त्यो किसिममा चाहिँ त्यो पर सेकेन्डको डाटा लिँदाखेरिमा एकदम 20 GB 30 GB को डाटा भयो के अनि त्यसले गर्दा लोड त्यसलाई चाहिँ म्याटल्याबमा लोड गर्दाखेरि म्याटल्याबै ह्याङ हुने त्यो किसिमको प्रब्लम भयो थियो अनि फाइनली मैले चाहिँ त्यसलाई के गरेँ भन्दा एउटा प्याटर्न एउटा सिटको चाहिँ लोड प्याटर्न अब म्यानिभुएर गर्दा के हुन्छ हैन अनि हाई स्पिडमा चल्दाखेरि के हुन्छ अलिकति मिडियम स्पिडमा चल्दा के हुन्छ त्यसको जस्ट प्याटर्न मात्र दिएर मैले फाइनली सिमुलेसन गरेँ जस्ट 120 सेकेन्डको लागि अनि फाइनल रिभ्यू चाहिँ के आएको थियो भने यसरी हामीले चाहिँ त्यसलाई चाहिँ लिन सक्दैनौँ, फुल डाटासितै लिनुपर्छ, नत्र भने यस्तो एकुरेट मोडेल आउँदैन भन्ने किसिमको आएको थियो होइन। अनि त्यसलाई फेरि मैले फाइनल्ली डिफेन्ड गर्दाखेरिमा चाहिँ अब हाई फिडेलिटी मोडेलमा हामीले यसरी गर्न सकिँदैन भनेर डिफेन्ड गरेर पास भएको थियो। तर यदि त्यस्तो केस आयो भने, त्यसरी हाई एमाउन्टको डाटा 20 GB 30 GB डाटा आयो भने त्यस्तो डाटालाई चाहिँ हामीले कसरी म्यानिपुलेट गर्न सकिन्छ होइन, त्यसरी सेकेन्डमा चाहिँ सिमुलेट गर्नको लागि अथवा त्यस्तो खाले डाटासित अपडेट गर्नको लागि कसरी गर्न सकिन्छ, केही आइडिया थियो कि सरसँग सेयर गर्नुहुन्थ्यो कि भनेर।
थ्याङ्क यू सर। अनि मैले अलि चिनिनँ कि के भयो नाम मैले।
तर म चाहिँ डब्लुआरसीको प्रोजेक्ट हामी इजेन क्लबदेखि एकचोटि हजुरलाई त्यो म्याटल्याबको प्रोग्रामिङ पनि गर्नको लागि क्लास राखेको थियौँ हामीले होइन, त्यहीँको प्रोडक्ट डब्लुआरसीको।
It's my really pleasure time. That time I conduct one program that is for MATLAB program after I have completed my master. Okay, thank you. मैले अहिले एकदमै फेस याद आयो है त्यो बेलाको, यहाँ अहिले मैले फेस देख्न सकिनँ। ल थ्याङ्क यू भेरी मच। मैले आज यो सुरुमा अलिकति कुरा गरेँ कि गरिनँ थाहा भएन, यो त एकदमै इम्पोर्टेन्ट तपाईँले अहिले भनेको कुरा त। इट्स भेरी इम्पोर्टेन्ट इन डेटा साइन्टिस्ट इन एनालाइसिस फिल्ड। किन भन्दा हामीसँग तपाईँले भने जस्तो अति धेरै डेटा हुन्छ, त्यसलाई अझै त्यो इन्कोडिङ गरिसकेपछि झन् धेरै डेटा हुन्छ होइन। त्यसलाई मैले एउटा ग्राफ देखाएको थिएँ डाउन स्केटिङ गर्ने सकभर, त्यसलाई चाहिँ कस्तो भने 32 बिटको छ, सरी 64 बिटको छ, किनभने हाम्रो कम्प्युटरहरू 64 बिटको हुन्छ, सबै डेटा त्यसमा हुन्छ। तर जस्तै हामी आफै भन्छौँ नि 2 भनेको त 1 0 हो नि होइन, 1 र 0 दुईटा बिट भयो पुग्छ भने हामीलाई त्यो 64 बिटमा लेख्नु पर्यो भने त अरू 62वटा जिरो त यसै बस्छ त्यहाँ होइन। त्यसरी हामीले रिड्युस गर्छौँ, विच आई जस्ट मेन्सन बिफोर होइन। त्यसपछि त्यो बाहेक अर्को छ हामीसँग स्याम्पलिङ टेक्निक भन्ने छ। त्यो स्याम्पलिङ गर्दा फेरि तपाईँको डेटा टाइम सिरिज हो कि अर्को जेनरल रिग्रेसन डेटा हो, इट डिपेन्ड्स है। फेरि अब टाइम सिरिज डेटा हो भने त्यसमा हामी स्ट्रेटिफाइड स्याम्पलिङ भनेर छुट्टै त्यहाँ हामी होइन वी क्यान गुगल स्ट्रेटिफाइड स्याम्पलिङ टेक्निक हामी युज गर्न सक्छौँ, जसले के गर्छ त भन्दा कति पर्सेन्टमा कन्भर्ट गर्ने सिम्पल त्यो ट्रेन टेस्ट स्प्लिट भन्ने एउटा फङ्सन छ पाइथनमा होइन, त्यो एस्केलर्न लाइब्रेरीबाट त्यो आउँछ। त्यसले चाहिँ कति पर्सेन्टमा कन्भर्ट गर्ने, जस्तै तपाईँसँग मसँग 10,000 डेटा छ भने त्यसको 10% लिने भनेपछि एउटा 10% मात्रै आउने भयो, 1,000 समथिङ आउने भयो होइन त हो। यसरी हामीले त्यो डेटा लिन्छौँ। त्यो लिँदाखेरि फेरि जहाँ पाए त्यहीँबाट लियो भने त ठिक भएन, त्योबाट त्यसलाई हामी चपिङ तपाईँले अघि भने जस्तो त्यसलाई त्यसको यु क्यान सी द डिस्ट्रिब्युसन होइन, त्यो छुट्टै छुट्टै आवर बनाएर त्यो कसरी बाँडिएको छ त्यो हेरेर त्यसको डिस्ट्रिब्युसनबाट तान्न सकिन्छ। तर त्यो सबै हामीले गर्नु पर्दैन, त्यो अलरेडी फङ्सन वी हेभ स्ट्रेटिफाइड फङ्सन भन्ने हुन्छ, स्ट्रेटिफाइड स्याम्पलिङ फङ्सन पाइन्छ, त्यसले गरिदिन्छ वाट एभर डेटा यु वान्ट इट डु है। सिम्पल छ, गर्न सकिन्छ। अब त्यसको इम्प्लिमेन्टेसन गर्दा तपाईँको रिजल्ट कस्तो आउँछ त्यो तपाईँको रिसर्च अब्जेक्टिभमा डिपेन्ड गर्छ होइन। एक्ज्याक्टली अर्को जस्तो त हुँदैन, केही न केही डेटा त लस हुन्छ नै, तर हामीसँग त्यो कम्प्युटिङ पावर हुँदैन, त्यो भएर वी मस्ट रिड्युस द्याट है, होइन भने हामीले गर्न सक्दैनौँ, हाम्रो कम्प्युटरले धान्दैन। ओके
हस् सर, धन्यवाद। अनि त्यो अर्को प्रब्लम पनि हुँदो रहेछ, यस्तो डाटा धेरै भयो भने हाम्रो ग्राफिक्स प्लटिङहरू गर्नेमा अब रिजल्टहरू हामी प्लट गर्छौँ भने ग्राफिक्सले ह्यान्डल गर्न नसक्ने
एक्ज्याक्टली यु आर भेरी राइट। म आफै त्यो गर्छु होइन, म आफै त्यो स्याम्पलिङ गर्छु, किनभने मसँग थुप्रै डेटा हुन्छ। मैले त्यो सबै त्यो मैले गुगल कोल्याबमा गर्दाखेरि पनि त्यो पेज क्र्यास हुन्छ, आई मस्ट स्याम्पल इट, स्याम्पल गर्नै पर्छ होइन। अब फाइनल साँच्चै कि त्यसलाई फाइनल इम्प्लिमेन्ट गर्ने ठाउँमा अब त्यस्तै पावरफुल सुपर कम्प्युटरहरू हुन्छ होइन, त्यसले चाहिँ गर्ला, होइन भने यो जिपियुले टिपियुले पनि भ्याउँदैन कि, वी हेभ टु स्याम्पल इट, यु आर राइट है, हामी स्याम्पल गर्नै पर्छ।
हुन्छ सर, धन्यवाद।
Okay, thank you, Anil sir. Now we are almost at the end, and I'm very much pleased the way Dr. Sapagai discussed and presented the overall content. exactly it was the way I was expecting. Thank you very much, sir. We also look forward to collaborate with you and with your institution in the future as well. Uh, Also, I would like to thank all the audience for staying with us throughout the program, for your patience. Now, before leaving, I would like to so before leaving, once again, I would also like to thank all the faculties who supported us in this program. And so at last, I wish you all the very prosperous and healthy Baradase, Bihar and Chhat. Thank you once again.
धन्यवाद धन्यवाद मिस मेरो तर्फबाट पनि हजुरलाई र सबै सरहरू त्यहाँ अनिल सरलाई चिने मैले अहिले बल्ल फेस याद भयो अनि सम्पूर्ण WRC को सरहरूलाई मेरो शुभकामना छ मेरो क्रिम टाइम almost 10 more than 10 years I spent over there